Everybody agrees there are some interesting and unique life forms in the Ediacaran, but even after, decades of being aware of them, there have been many paleontologists, many paleobiologists who would say, yeah, they were sort of an evolutionary dead end, an interesting type of group of organisms that went extinct, and they did not give rise to the Cambrian animals. Whatever they were, that they're not the evolutionary precursors that we need to find to explain how the Cambrian animals evolved.
ID, the Future, a podcast about evolution and intelligent design.
New fossil discoveries from China are being hailed as evidence that could reshape our understanding of the origin of complex animal life. Well, does the new find solve the mystery of the Cambrian explosion? Are the headlines about these fossils justified? Are these, in fact, the long-lost ancestors of the Cambrian animals that we've been all looking for? Well, let's find out. Welcome to ID the Future. I'm your host, Andrew McDiarmid. Today, Dr. Casey Luskin joins me to examine the evidence, the ambiguity, and the ongoing controversy surrounding newly reported Ediacaran bilaterians. Casey is a regular voice on ID the Future, but for those of you who may not be so familiar with him, he serves as Associate Director of Discovery Institute's Center for Science and Culture, where he helps direct the ID 3.0 research program and assists and defends scientists, educators, and students who seek to freely study, research, and teach about the scientific debate over Darwinian evolution and ID. He holds a PhD in geology from the University of Johannesburg, as well as graduate degrees in science and law, giving him expertise in both the scientific and legal dimensions of the debate over evolution. Dr. Luskin has been a California licensed attorney since 2005, practicing primarily in the area of evolution education in public schools, as well as defending academic freedom for scientists who face discrimination because of their support for intelligent design. On top of all this, it's worth noting that Casey was the primary research assistant for Steve Meyer when he wrote the book Darwin's Doubt about the Cambrian explosion. I think Dr. Meyer writes in the acknowledgments of the book, Casey Luskin, my research assistant, has repeatedly gone above and beyond the call of duty in his commitment to and skillful work on this book. So, Casey, this topic is not new to you, and you've got a lot to say about it. Welcome to the show.
Thanks, Andrew. Yeah, bring back some good memories of working with Dr. Meyer alongside of him as he wrote that book, and it was a lot of fun. It was a great book, too. I was very proud of what he produced.
Yeah. Well, first things first, for those not familiar with the debate in general, can you remind us what exactly is the Cambrian explosion, and what do we need to know about the period before it, the Ediacaran period?
Sure. So the Cambrian explosion is what is referred to as the sudden appearance, geologically speaking, of the vast majority of the major animal phyla in the fossil record in a very short geological amount of time during the Cambrian period, some 520, 530 million years ago under the standard view. And so it's been argued by many folks that this is a challenge to standard evolutionary biology explanations of how new types of organisms arise. I think Richard Dawkins once said that when speaking of the Cambrian organisms, that it's as if they were just planted there without any evolutionary history, okay? So that's kind of the problem, that there are no clear, direct evolutionary precursors to the vast majority of these Cambrian animals, and certainly not enough time for all of this diverse complexity to evolve under standard evolutionary mechanisms. So the Cambrian explosion is cited by us folks and the ID community as a major challenge to evolutionary biology and also as evidence for intelligent design. Because what we see in the Cambrian explosion is the very sudden appearance of massive new amounts of biological information showing up in the biosphere as new body plans. All these different body plans of organisms that appear in the Cambrian, whether they're vertebrates or echinoderms or arthropods or bryozoans, et cetera, they all represent new genetic information that had to be inputted into the biosphere. So what we're really seeing in the Cambrian explosion is an explosion of new biological information that manifests as the abrupt appearance of all these different types of organisms, very diverse types of organisms. So, and of course, animal phyla. Phyla are one of the highest taxonomic categories. So we're talking about very broad groups of animals. Again, things like vertebrates or, again, echinoderms or mollusks, or placozoans. These very, very large taxonomic categories that represent broad diversity that appears in the Cambrian. So then what is the Ediacaran? The Ediacaran is simply the geological period before the Cambrian, okay? And yes, there is life in the pre-Cambrian Ediacaran period. The question is whether or not it represents life that could be ancestral to the Cambrian animals. And there's been a lot of debate about what we should make of these very strange organisms that appear in the Ediacaran. Some of them look like weird frond-like organisms with strange types of symmetry that we don't see in living organisms today. Could they be algae? Could they be fungi? Could they be plants? Could they be animals? Could they be some strange combination of all the above? Nobody really knows. I would say what I should say is that there's a lot of disagreement about that. But this new paper that we'll talk about is claiming to have found not just animal fossils in the Ediacaran period, but actual bilaterian animal fossils, which would make them quite advanced, perhaps as advanced as many of the Cambrian animals.
Okay. So the debate lies in how some scientists tried to line up fossils from the Ediacaran period to function as evolutionary precursors to the Cambrian animals. Is that right?
That is exactly what the debate is. A lot of folks, I mean, everybody agrees there are some interesting and unique life forms in the Ediacaran, but even after, decades of being aware of them, there have been many paleontologists, many paleobiologists who would say, yeah, they were sort of an evolutionary dead end, an interesting type of group of organisms that went extinct, and they did not give rise to the Cambrian animals. Whatever they were, that they're not the evolutionary precursors that we need to find to explain how the Cambrian animals evolved. Some people would say they are the evolutionary precursors. I would certainly say that's a very dubious claim.
Yeah, so this recent fossil find that the paper's about that you've been covering, did they find any good examples of animals?
I think they do have a couple good examples of animals in this paper. Now, animal fossils have been known from the Precambrian for a long time. We've known that there are, for example, cnidarians, essentially organisms that are kind of like jellyfish, and also sponges have been long known from the Ediacaran Precambrian period. And so this is not anything new to find organisms that could be classified as sponges or cnidarians. The question is whether or not they're adding new types of animals that were not previously known. One in particular type of organism they claim to have found is a ctenophore. Ctenophore is not a bilaterian animal, I used that term earlier, is an animal that basically has left and right-sided symmetry. Okay, so we are a bilaterian. If you look at a bug, a fruit fly, that's going to be a bilaterian. If you look at a snail, a mollusk, that's going to be a bilaterian. Okay, so many of the animals and organisms that we're very familiar with in our everyday experience are going to be bilaterian animals. Even in echinoderm, which, things like a starfish, they have certain larval stages that have a bilaterian symmetry to their body plan. So they are considered to be bilaterians, although, they have other life stages that are not necessarily just a straightforward bilaterian. But anyway, so the point is that what they found in the Precambrian so far are not bilaterian animals. They're animals with, say, radial symmetry or some other type of symmetry that is a much simpler form of symmetry. Radial symmetry would be, circular symmetry. That would be like what a jellyfish has. Sponges really seem to be asymmetrical. They don't have a form of symmetry. It's kind of a very strange body plan. So the one animal they found in this paper published in Science that was claimed to be a non-bilaterian animal that we would recognize today was a ctenophore, comb jellies. They actually have kind of advanced nervous systems, but they do superficially look like a jellyfish. And so given that those sort of, fauna was already present, I don't think anybody would have been too surprised to find something like a ctenophore in the Ediacaran period. However, we can talk about this more. There's actually, I think, some pretty good reasons to doubt that they did find a ctenophore. But then they claim to have found bilaterian animals. I don't know if you want to talk about that at all.
So this paper in Science claimed to have found bilaterian fossils in the Precambrian Ediacaran period. Would this have been something new? And were there potential examples of bilaterian fossils convincing?
Yeah, so if they had found bilaterian fossils in the Precambrian, it would have been something new. People have proposed that there were bilaterians present for a long time, but they usually find what we would call trace fossils. And the problem with trace fossils is that they can be produced by a variety of different mechanisms. So even bacteria, or maybe just a stone, rolling along the bottom of a lake bed or a stream, being carried along by the current, could produce something that looks like a worm track or a bilaterian trace fossil. So bottom line is, up to this point, I think that there have not been very clear-cut examples of bilaterian fossils. And so were they convincing? That's another question. There were 4 different types of organisms that this paper produced, which they claimed were bilaterian fossils, okay? So one of them, and again, we can't really show these pictures because they're all copyrighted images, and it would be very complicated to get permission to show these, but we can talk about them. So if you look at the paper, if you download the paper and you look at figure 3, which supposedly shows their bilaterian fossils, there's one that's labeled A to E, and this is the most numerous fossil they find. It's a very, very strange fossil for this to be an animal or a bilaterian, because it has what we would call a holdfast disc. Okay, it's basically anchored to the seafloor through this discoidal shaped holdfast. Nobody knows of something that has a gut and a mouth with a holdfast disc in the animal kingdom today. Okay, that's completely unknown. So if this did exist and it was an animal, that would be very, very strange. The bottom line is that this is a very, I would say, poorly preserved fossil, and what they claimed to be a feeding structure or a mouth with a gut in this fossil, I think, is not at all clear from the very poor preservation. In fact, another paleontologist named Joseph Botting did an analysis of this fossil, and he said that what they claimed in the fossil was a gut is very dubious, because there are these long kind of thin black lines, and there are multiple of them. So if they are in fact guts, then this thing had multiple guts, which is very, very strange. Something else seems to be going on here. Whatever it is, the case for it being a bilaterian animal with a mouth and a gut, I think the preservation is just far too poor to say that clearly, and really actually even points against that. So that's animal number 1, or organism, we should say, number 1. So the second organism that they found that they claimed was a bilaterian animal was also in figure 3, labeled I through L. And it's sort of this elongate, tube-like organism that's also not very well preserved. And if you look at it, you will immediately say, where's the bilaterian symmetry? Remember where's the beef commercial from the 1980s? It's like, where's the bilaterian? Okay, I don't see it at all in what they actually found. It is not bilaterian symmetry, what they actually found. Okay, it's just not. So it looks actually, in my opinion, a lot like a piece of kelp, which of course is a form of marine algae, not even a plant or an animal. However, they're claiming that this fossil is similar to something else that is known later from the Cambrian, called Margaritia, I believe. And that, I think, is the argument they'll say, is that organism was, in fact, a bilaterian. The problem is that tube-like organisms that kind of look like kelp with these perforations are not that unusual. In fact, you can see them alive today, and clearly they're not animals. So it's very hard to rule out the possibility that these are superficial or convergent similarities to this other organism called Margaritia. And in fact, it has some differences from Margaritia as well. So I'm definitely not sold on that one. What they actually report in the paper is not, clearly not bilaterian symmetry, and I don't think they've made a solid enough case yet. And even Margaritia has been interpreted in different ways. So then we have an organism that they label as F to H. It's sort of this S-shaped organism, which they claim in the paper potentially indicates body contraction after death or during burial. Now, they claim this is a worm-like organism with a circular terminal opening interpreted as a mouth. Okay, and that's possible. I'm not saying you can rule that out. However, this fossil is also very poorly preserved, and even the figure labels the mouth and the gut with a question mark. Okay, so it's pretty ambiguous in my opinion. I don't think you can say for sure what this is, much less that it had bilaterian symmetry, and I think that it's just not well enough preserved to say for sure. And then finally, Andrew, there's an organism that they label M through P or Q and R, which I think is their best case for a bilaterian. I'm not 100% sure I know what this is, that is a bilaterian, but it's certainly their best case. They claim that they found tentacles, and they classify it as basically belonging to an organism known from the Cambrian period called a Cambrianid. And I hope that I pronounced that correctly. This is one of those words that nobody ever says unless you're talking about these very specific subfields of Cambrian paleontology. But Cambrianids are thought to be a stem group echinoderm, and sort of not directly related to echinoderms, but sort of on a branch that went extinct. But if you go to the base of that branch, it would have been on the line that led to something like an echinoderm. The problem here is that, according to actually the analysis by Joseph Botting, this paleontologist who did an analysis, this organism seems to be possibly have a branched stock, which means that it might be colonial. If it's colonial, it's not a Cambrianid, okay? Also, the so-called tentacles that it has look very, very different from tentacles that are known from actual Cambrianids in the Cambrian period. So I think that we are dealing with a potential bilaterian fossil here, but we need more data on this before we can say for sure. We need better preserved fossils, and we need to be able to better link it to actual Cambrian organisms. What I can say is, even if it is a Cambrianid, okay, even if we sort of take their best case scenario interpretation of this fossil, that does not make it ancestral to any of the Cambrian animals. Cambrianids are thought to have been and again, forgive me if I'm not saying that quite right, but Cambrianids are thought to have been basically an evolutionary dead end that went extinct without evolving into any of the major animal phyla that appear in the Cambrian and that we would recognize today. So I would say that the number of organisms that they have found that officially represent known Cambrian animal phyla is 0. And that is also because the ctenophore that they found, or what they labeled as phylum Ctenophora, is dubious as well. In fact, this analysis, I said in my initial analysis that I didn't really, have much skepticism that it was a ctenophore. But Joseph Botting, this other paleontologist, says, I do not see any reason you could call that a ctenophore, and he actually calls it the least convincing assignment of all their fossils. So if that is true, then I would say, again, the number of examples of Cambrian animal phyla that this paper newly establishes as present in the Ediacaran officially is 0. So very interesting fossils they found, but I don't think that it is actually explaining the Cambrian explosion.
Okay. Yeah, that's a great analysis of the fossil finds, these strange and exotic creatures that have been found. Now, you've been covering this story in a series of articles at Science and Culture Today. In your first article, you talk about retroactive confessions from evolutionists. Can you tell us what you mean by that?
And this is kind of a fun rhetorical trend that we've observed over the years, that evolutionists will often only admit a problem with their theory once they think they found a solution to it, okay? And once they find a solution to it, then they're like, oh, we had this big problem that was unsolved, but it's solved. Isn't that great news? It's always great news all the time and only great news ever, okay? That's kind of the rosy picture they want to paint. So we saw that going on with this paper in the journal Science that purported to find these pre-Cambrian bilaterian animal fossils. And we found quotes from an article at The Conversation, sort of a big, academic science news website that was written by some of this paper's authors that said, the preceding Ediacaran period was much more enigmatic than the Cambrian. Many organisms from that period have defied efforts to classify them. Their strange bodies, often resembling shapeless sacks or thin quilted pillows, have no obvious counterparts among living species, let alone modern animals. Okay, so here they are basically admitting that the organisms that lived in the Ediacaran don't look anything like modern animals or what we even find in the Cambrian. Okay, and so isn't that interesting? I thought that before this, we were told many times that we found all these pre-Cambrian ancestors to the Cambrian animals in the Ediacaran period, but apparently not. Apparently they have no obvious counterparts. So we're seeing this retroactive confession of ignorance, that they're acknowledging that really we did not know, what was evolving into the Cambrian animals prior to this. However, of course, they then claim that we have many Ediacaran fossils that are bilaterians. And same thing from Scientific American. They said before this paper, essentially, scientists thought that bilaterians arose primarily during the Cambrian period and were rare, certainly not diverse and flourishing in the Ediacaran. Okay. Now, I would say that there's a danger when they make these retroactive confessions of ignorance, because what if the evidence that you are bringing forth that supposedly is solving this problem doesn't actually plug the gap, doesn't actually solve the problem? And in this case, I would say at best, they have one, maybe two fossils that are candidate bilaterians. Even then, the preservation is not good enough to really say for sure. And they have some traits that certainly distinguish them from the Cambrian animals. So I don't think that this case has been made. But in the best case, they found only 4 potential bilaterians. That does not equate to bilaterians being diverse and flourishing in the Ediacaran, as Scientific American says. So yeah, we saw these interesting retroactive confessions of ignorance accompanying this science paper, and it's always amusing to see how that works in the literature and in the press.
Yeah, playing it safe for sure. That's a good method to do that. Now, you recently, another thing I appreciated about your series was you shared about this beach stroll and what it sort of illuminates about these interpretations that they're making about animals. You recently had the chance to do some beach combing and tide pulling with friends here in Western Washington, and you mentioned a few finds from your beach stroll that can help us understand why mere similarity does not necessitate an evolutionary relationship. Can you share that story briefly with us?
Yeah, we just went out to do some tide pooling and beach combing and actually fossil hunting here in Western Washington with some friends. Right after I had written up this analysis of these fossils, and we found lots of different interesting types of kelp while we were out there that day. And one of them had a holdfast, okay? Basically what would hold the kelp down to the ground. Now, it wasn't a discoidal holdfast like that very strange organism, but it had a holdfast, which just shows that, you can find similar traits among organisms that are clearly distantly related or very, very far removed from these fossils that you're interpreting as precursors to the Cambrian animals. But the one that was really the kicker for me was I found this rotting kelp stipe. That's basically those long kelp tubes that are attached to the air bladders. And it was starting to decay, and it looked so much like this one fossil that this paper had interpreted as a Margaritia from the Cambrian period. And I thought, you know what? If you can have something like a kelp that convergently looks so much like this fossil, how can they say with any confidence that they know that this was Margaritia in the Ediacaran? Again, I may be mispronouncing these. I hope I'm not. But the bottom line is we have to be very careful with convergence, where things independently look similar. And what was strange was that the science paper really did not express, it never went into the possibility that these similarities to so-called Cambrian animals were convergent. It never really engaged or entertained that possibility, even though, take a walk on the beach and you'll see there's convergent similarity all over the place.
Yeah. Now, since your first articles about this, additional criticism and skepticism has come to light about this new fossil find. You mentioned paleontologist Joseph Botting. Can you summarize some of the other skepticism that's coming out? I know there was another paper urging caution when interpreting supposed Precambrian animal fossils. This isn't just us saying this stuff, is it?
Yeah, I mean, Joseph Botting is an honorary research fellow at the National Museum of Wales and an independent paleontologist, and he posted a very nice analysis of these fossils. I had not seen it before I posted my analysis. A friend, actually a summer seminar alumnus, one of the students in our network, passed this along to me. And what was interesting is that in some cases, he came to parallel conclusions that I did, maybe not always for the same reasons, but in some cases, he actually expressed more skepticism towards the conclusions of this science paper than I had. So I was very gratified and encouraged to find that I was not the only person who found some of these bilaterian animal fossil claims to not be very convincing. But I also found another paper that just came out in the journal Gondwana Research that again further reminds us why we should be cautious when interpreting supposed Precambrian animal fossils. Basically, this article finds that what was once thought to be trace fossils of animals in the Ediacaran were actually algae or bacteria. So again, you've just got to be very, very careful with interpreting. You find something you think, oh, this looks like a worm track, or this looks like a worm, okay? And there is so much opportunity for other processes to be at work or convergent similarity. You have to be very, very careful. So this was a paper that was looking at supposed animal trace fossils from the Ediacaran and basically said, no, these are actually made by bacteria or algae.
Well, your final article in the series pays homage to our friend, the late paleontologist, Dr. Günter Beckley. You say even if we took the claims of this new fossil find at face value, the Cambrian explosion is not diminished in any non-trivial way. That's a strong argument that Dr. Beckley made. Can you explain how it's holding up, how it's true?
Yeah, so Dr. Beckley, of course, was a paleontologist. He passed away at the beginning of 2025 in a car crash. Very, very sad. And we certainly miss him here at Discovery. He was a good friend. So what's interesting is that he actually, in an article he wrote back in, I think it was 2024 or 2022, rather, he actually sort of predicted the possibility that someday we might find more complex animals in the Ediacaran. I think the best thing to do is just let Gunter Beckley speak for himself here. Here's what he wrote, okay? Even if some relatives of sponges, cnidarians, and stem eumenozoans, and maybe even some stem bilaterians should be present in the Ediacaran. That's exactly what this paper claims to find, stem bilaterians. He said this would do absolutely nothing to explain the sudden appearance of the different bilaterian animal body plans in the Cambrian explosion. They do appear as if out of nowhere, and that is not just a claim by Stephen Meyer. Here's what the great apostle of Darwinism, Richard Dawkins, has said. The Cambrian strata of rock, vintage about 600 million years, are the oldest in which we find most of the major invertebrate groups. And we find many of them already in an advanced state of evolution. With the very first time they appear, it is as though they were just planted there without any evolutionary history. And then he goes on to say, look, and this is a really important point, that even if you do find organisms that appear in the Cambrian explosion further back, and maybe it extends the Cambrian explosion, the length from being 5 to 10 million years to maybe 20 to 25 million years, okay? And these fossils, by the way, that were reported in the science paper, it's not entirely clear how old they are. They might be right up against the base of the Cambrian period. So they could be 539, 540 million years old, or they might be a few million years older. But at most, they're, maybe not more than 10 to 15 million years maximum below the Cambrian, pre-Cambrian boundary, okay? But I think it's actually, and Joseph Botting agrees, he said the same thing, it's actually probably pretty high in the Ediacaran stratigraphy and pretty close to the pre-Cambrian Cambrian boundary. But whatever it is, let's say that these fossils somehow extended the Cambrian explosion to be 25 million years. That does not actually change the situation for the problem for neo-Darwinism. And here's what Gunter Beckley says. It does not make a significant difference for the problem of the Cambrian explosion, whether it lasted 5 million years or 25 million years, because even the latter range would be orders of magnitude too short to accommodate the origin and spreading of the required genetic characters based on standard population genetics. And of course, Gunter and others have written on the waiting times problem that you would require many, many tens of millions of years just to get, say a trait that requires 2 mutations before giving you some advantage, okay? 2 specific mutations. So again, 5 million years, 10 million years, I think there's still a good case to be made. The Cambrian explosion, this very dramatic pulse of innovation, happens in that short time period. But even if you found evidence that it was longer, that does not mean that somehow, Darwinian macroevolution can explain the data. You've still got a big waiting times problem. Too many biological changes, too much information being generated in too short a period of time.
Yeah, such good points from Dr. Beckley, and as you point out, very sorely missed by all of us here. Well, Casey, final question for you. This is something to leave our audience with. The next time they see headlines claiming that an evolutionary mystery like this has been solved, what should they keep in mind?
Well, first of all, it's exciting to make new scientific discoveries. This is a really cool scientific find. These fossils are interesting, and maybe they will turn out to be bilaterians. I don't think the case is totally solid yet, so we should always keep an open mind. But you should also be cautious about the hype. And I think we did see some hype in this case. They're acknowledging that, none of these Ediacaran fauna that we knew before were ancestral to the Cambrian, but now we've solved the problem. Okay, well, how do we know there aren't problems today that are not being fully disclosed? Okay, and I think that in this case, for me, one of the big red flags of this paper was it really did not even engage or entertain the possibility of convergent similarities. And I was like, wow, that's just striking, because I think that that would be one of your first possibilities you would consider. At least they didn't consider that enough. So in any case, I think we should always be skeptical, but also keep an open mind. Maybe this will turn out to be a bilaterian in the Precambrian. Again, I don't think it's been a solid case made yet, but it could be. And it's a very interesting fossil. So I look forward to seeing what the evidence says when more folks do analyses of these fossils.
Yeah. And our audience can go and read your series on this. That's at scienceandculture.com. And of course, Darwin's Doubt, great resource to dive into the explosive origin of animal life and the case for intelligent design. So we highly recommend that book as well. Casey, thanks so much for stopping by and sharing this.
Thanks a lot, Andrew. It was a lot of fun.
Well, this show exists because listeners and viewers like you keep tuning in. So consider subscribing to our YouTube channel so you can be among the first to know about new interviews coming out. You can also share an episode with a friend or a colleague to help answer a question or just start a conversation. Thank you for your support. Well, I'm Andrew McDiarmid for ID the Future. Thanks for joining us.
Visit us at idthefuture.com and intelligentdesign.org. This program is copyright Discovery Institute and recorded by its Center for Science and Culture.